Okay, this is class number 21, and it's percentages and simple interest, and it goes with sections 10.1 and 10.2 in your textbook. All right, our daily summary. In this lesson, we're going to review percent and percent applications and explore simple interest, bonds, CDs, savings accounts, and payday loans. All right, in our demo section, number 1, since many people don't like dealing with fractions, and because fractions with different denominators are hard to compare, we have developed a common standard denominator of 100. A fraction with a denominator of 100 can be interpreted as a percentage and uses the percent symbol to indicate the presence of the hidden denominator 100. Thus, x percent is equal to x over 100. As an example, if you take 50%, that represents the fraction 50 over 100, or 1/2 if you reduce that. Okay. Percentages provide a nice way of making comparisons. They provide a useful way of dealing with fees, taxes, and tips, and they help us better understand how things increase or decrease relative to some baseline. Okay, number 2, suppose that in your English Lit class you scored 19 out of 25 on the quiz, 49.2 out of 60 on the midterm, and 124.8 out of 150 on the final exam. Which one was your best score? So let's take a look at the quiz, your midterm, and the final exam. All right, so on your quiz, you scored 19 out of 25. Oops. I hit the screen over here, 19 out of 25. On the midterm, you had 49.2 out of 60. And on the final, you scored 124.8 points out of 150. So here's the first problem. All your denominators are different, so it makes it hard to compare. So in percent, step in and say, let's standardize this. Let's convert them all so that they're out of 100 points. And then we can see which of the 3 you did better on. And so I'm going to give you 2 techniques here to use, and you can decide which one makes more sense for you. Here, notice that if we multiply 25 by 4, we need to do the same thing to the top to get our equivalent fraction. We can see that this score on your quiz is equivalent to scoring 76%, where you got 76% of the points. Over here, that's a little tougher to do, so I'm going to give you a second option. So remember that division sign in the middle. That's all that is. That fraction bar in the middle means divide. So if you carry out that division, you get 0.82. So now our equation is 0.82 equals something over 100. So I'm going to put x over 100. And then we're just going to multiply both sides by 100. And by the way, if you remember the shortcut that you can just move that decimal point over 2 places, that's fine. So that you got 82% on your midterm exam. All right, so if we do the same thing on this last one, take 124.8 divided by 150, we get a score or a decimal 0.832, and we're just going to multiply that by 100. And that gives us a score of 83.2%. So we can see that you did the best on your final exam. So which one was your best score? That was your final exam. So again, converting them to a fraction that has 100 in the denominator makes that comparison a lot easier. Okay, so number 3, imagine you're shopping for a new iPod and you have 3 options. We want to figure out which one is the best. So in part A, you can get your iPod from Optimal Buy for $399 plus an additional 5% sales tax. All right, so we want to figure out what's the final cost. So if you have a 5% sales tax, 5% means 5 out of 100. And if we carry out that division, we get 0.05 for a decimal. And now we can take that. We want 5% of 399. We're going to multiply. So I'm using X for my multiplication sign here. And grab a calculator to verify this. But that is going to add on another $19.95 in tax. So your total price is going to be $399 plus the $19.95. And that gives you a total of $418.95. Well, now if we take a closer look at how we did this calculation right here, we can say that we used 1 full price, so 1 times $399. Plus remember, this came from doing 0.05 times $399. And those of you that have been in algebra recently, you might remember factoring. We can pull out that common factor of 399 and get our total price by doing 399 times what's left. We've got 1 plus 0.05. Or we could just do 399 times 1.05. And double check with your calculators, but that should give you the same price that we got above. So we got a shorter way to handle that. All right, in part B, we're going to get the iPod from Hamiltonian Circuits for $415. This time we have a 5% off coupon plus an additional 5% sales tax. So if you're getting 5% off, that means you're paying the other 95% of that cost. So let's use that to our advantage. Let's figure out what 95% of $415 is. Right? That gives you a price of $394.25. And note that we can also think of this piece here as 1 minus 0.05. So it starts to look a little similar to what we did in part A. All right, we're not done yet. We still need to add in the tax. So I'm going to use what we learned up above. We're going to take 1 plus the tax, 1 plus 0.05, which is 1.05, and multiply that times our price. So we're going to multiply that times the 394.25. And that gives us a price of 413.96. And if we want to find out a little bit more information about that, if you want to know how much there was for tax and not just what the final price is, remember that you can take 0.05 times 394.25. This is another way around the problem. And you'll get, let's see, our tax would be 1971. And grab a calculator, don't just take it from me, but double check these numbers. Okay. And so far, it looks like this is a little bit better deal than part A. All right, part C. You find an online merchant in Portland, Oregon that will sell you the iPod for $441, and this includes a 5% shipping charge. There's no sales tax in Oregon. Your friend from Portland is planning to visit, and you could ask her to pick up the iPod for you and save the shipping charge. I mean, so if you do that, how much is the iPod going to cost? Because remember, this price that's listed includes the shipping charge. So we have to figure out what it was before that was put in. Right, so we know that the shipping charge was 5%. So if we do 1 plus 0.05 or just 1.05 times the price, we should get the $441 that it's listed at. Right, so I'm going to set this up with X in there instead of price. And then we just need to solve for X. Right, so a little bit of review of algebra if you're a little rusty. We're going to undo that multiplication. Just divide both sides by 1.05. We're going to find that the price before all that shipping was added on was $420. Okay, so here, if you've been in algebra recently, you might remember that you should define your variables. So I'm going to put a reminder here that X is the ticket price of this iPod, and it's given in dollars. All right, so looking at our 3 options now, we're going to find that option B is the best deal. Okay, number 4, you have some formulas for percent increase and decrease, which is what we've just done, and number 3, but you really don't need to memorize them. In fact, if you look in your package, you're going to find a formula sheet. I'm going to skip to that. Looks something like this. You look down at the bottom, you're going to find these same 3 formulas we're just looking at right now. So keep that in mind. You may want to use that when you're doing your homework. All right, so for percent change, if you're increasing an original amount by X%, let's say you're increasing by 5%, like we did on the previous page because you've got to add on tax, then your increased amount, which is your total price with tax, is equal to the original amount, which is your ticket price. And this is just a specific example that I'm writing in green, times 1 plus that percent increase. So if it goes up 5%, 5 out of 100 is that 0.05 we were using. So again, this is just an example that I've written in here. Okay. If you're doing a decrease, so to decrease an original amount by X percent, remember on the previous page we had a 5% off coupon. So this is a good example of using this formula. Then your decreased amount, so we would call this your sale price, would equal your original amount, which again is your ticket price, times 1 minus, so you're paying less than 1 full amount. So in this case, we had a 5% off coupon, so that was the 0.05. So we took basically 95% of that ticket price to find our sale price. And then this third one we haven't yet done, but if we want to talk about percent change, we're going to need to know how much it changed by, so what's the amount of the change, and we have to know the original amount. So think of original as where it started. And we'll get some examples of that below. All right, so number 5, on a particular day, the Dow Jones closed at $12,875. The next, or not dollars, but points, I guess. The next day, the Dow closes at 13,029.5. So we want to find what's the percent increase. So we're doing percent change. So instead of putting percent change, I'm going to put percent increase, or we'll keep it as change. No, we'll switch it. We want to find the percent it changed by. Again, the change is specifically going up, so it's an increase. So we want the amount of increase. We're just being more specific to this problem. And we want to find the original amount. So we're going to fill in what we know. Okay, so we know that the Dow started at this. That's where it closed the previous night. So that's going to be our original amount. And we don't know the amount of increase, but we can find it. So over here on the margins, if we find the difference between where it is now and where it was, and I'll leave it up to you to verify this, but we'll find that that difference is 154.5. So that's the amount of the increase. That's how much it increased by. Okay, and that'll give us our percent increase. So if you plug that into your calculators, you're going to get 0.012 or 1.2%. And I'm going to give you a second option or second way to think about this. Sometimes it makes more sense to some people. If you forget to calculate that increase first, let's say you just take the new number and divide it by the old number, the original number, right? Notice that what you get is 1.012. So it looks kind of similar. You have this portion that we got earlier. If you do that, remember that this, the one that's in there, is the original amount. And this is what it increased by. So in other words, all you have to do is subtract 1 from that, and you'll be all set. And if you do that in percent form, you'll still be okay. So a second option, it gives you something to think about. And again, in your homework, you can try both ways, see which one makes more sense to you. All right, in part B, we're going to use that formula again. But notice that on the third day, the Dow Jones closed at 12,508.32. And now we want to figure out what the percent decrease is from the previous day. All right, so we're going to take the previous day's amount, which is 13,029.5. Going to subtract this new amount. So that'll give us the amount that it's changed by. And now the original amount is the 13,029.5. Okay. All right, so the original amount, again, is where it started. It's like your baseline. So this gives you a decrease of 521.18 up on the top. And we want to know what fraction of the original number that is. Okay, what fraction or what percent? So trying this out on your calculator, you're going to get 0.04 or 4%. And just as an aside, again, another note here, just like above, if you don't calculate that difference first, watch what happens. So notice we're taking the new amount and dividing it by the old amount. And that's going to give you an answer of 0.96 or 96%. So we're not seeing the 4% we had before. But what that's telling us is that that new amount is 96% of the old amount, which means there's a 4% difference, or in this case, a 4% decrease. So we just need to subtract that from 100%, and we'll get the answer we're looking for. Okay, number 6, a very important concept in the business world is that money has a present value and a future value. If you invest P dollars today for a promise of getting F dollars at some future date, you expect F to be more than P. Otherwise, why do it? So if we're given the present value, how do we calculate the future value and vice versa? The most important part of the answer depends on the interest rate. So interest is the return the lender expects as a reward for the use of his or her money, and the standard way to describe an interest rate is a yearly rate called the annual percentage rate, or APR for short. In simple interest, only the original money invested or borrowed, which is called your principal, generates interest over time. This is different from compound interest, where the principal generates some interest, then the principal plus the interest generate more interest, and so on. And we'll look at compound interest in the next class. All right, the simple interest formula. The future value F of P dollars invested under simple interest for T years at an APR of R% is given by this formula. So again, here's our future value, what we want it to be in the future. Here's your present value. So I'm going to put present or principal. Principal is what you start with. This is a constant, that's always in there. Here's your interest rate. And T is your time. And if your interest rate is annual, then this is going to be the number of years. Okay, just as an aside, I'm going to pull this over here and just show you one other way to write this. This can also be written as the future value is equal to, and all we're going to do is distribute the P over the two terms on the inside. So P times 1 is P, plus P times R times T. And so this allows you to see it as two pieces. Your future value is going to have the present value, or your principal, again, what you started with, plus your interest. So interest is in dollars. Interest rate, keep in mind, is in percent form. All right, so number 7, on the day you were born, your parents purchase a $1,000 savings bond that pays 5% annual simple interest. All right, so what is the value of the bond on your 18th birthday? All right, so using the formula for above, we're going to replace P with 1,000 because that's your principal. 1 again is your constant, so that stays in there. Here's your interest rate, R. So we'll convert that to decimal form. And then T, let's see, 18th birthday. So that means it's going to grow for 18 years. There's our formula. All right, so grab a calculator, try this out. Press pause if you need to. But double check that you get an answer of $1,900 as well. All right, so again, if we were to use that other formula, and this is the one I have in green up above. This would just help us see again the two pieces. We've got the $1,000 you started with. So if you calculate this out, you'll find that you have $900 in interest. So those of you that again have taken math recently, you might remember a formula where interest is equal to principal times rate times time. And that's just a portion of this formula for future value. Right, in part B, what is the value of the bond when you're 18.5 years old? Well, it turns out the answer to this is really the same as what we just found. because it's credited, or the interest is credited annually or calculated annually, means we're still only going to have $1,900 in there. In other words, to see this go up again, we'd have to wait till your 19th birthday to get to more money.